And welcome everybody to the Daily Space Weather. I'm your host, Dan, aka Smash-O-Mash, and congratulations on realizing the Smash News Network least busted name in news exists. You've found the most comprehensive daily space weather content and most detailed imagery you'll find of the closest star in the known universe. First thing we're looking at is a 24-hour video from Solar Dynamics Observatory. We're going to take a fantastic tour here. We've got at least 2 new sunspot groups, a bunch of sunspot groups that will be losing as they set on the western limb. Let's add 131 angstroms and get a little bit closer. Here's the northern hemisphere. You might see a huge filament over there. A new sunspot has risen way up there at high latitudes in the northeast. Here's a little closer look at that. Huge plasma filament, which we've featured on the last 2 days on the Daily Space Weather Show. There's an even closer view. Get great depth there of that, the size and height of that massive plasma filament. And here's the equatorial zoom. Again, we do have at least one new sunspot group that has spontaneously formed down in the southwestern limb there, in between that setting active region and another new sunspot group, also in the southern hemisphere. Here's the southern polar region. Not a lot going on over there. There has been a crown prominence that has recently cropped up. Here is an extreme close-up of those 2 new sunspots. They kind of just formed there. We'll also show an extreme close-up of the most active region, I believe. That should be the most active sunspot area there, that southwestern limb. Still a high likelihood to see large solar flares there, even though some of those sunspots are now out of view. And let's don't forget this area as well in the northwest. It has been producing some minor X-ray enhancements. So that's what's going on here at the moment. By the way, if you enjoy the content, don't forget to press the like button. Press like. If you're new to the channel, press the subscribe button. Do yourself a favor and get the world's most comprehensive daily space weather content delivered right to your YouTube feed. And if you're not seeing them, we've got some solutions for that as well. But in the meantime, press the like button. The video cannot continue until you do. Seriously though, folks, if you want more content, hit us up at smashomash.com/smashteam. So we launched it back in October of 2021. We do send out email alerts as people have been missing notifications about these videos. So catch that. There's a bronze level, there's a silver level, there's a gold level, there's even a gold annual paid up subscription at smashomash.com/smashteam. We also do have merch. So the Smash Team is one of our paid endorsements. Here's another one. Since you're sick, stay home. We would encourage people who are sick to stay home. So, of course, there are many ways to protect others. And perhaps if you're an imbecile, protect others from your imbecile behavior by staying home. Who knows? Just saying. So if you're sick, or in this case, since you're sick, because you're masked, stay home. That's today's featured merch item. And the featured product from the Amazon store today is, by the way, you can find our supplement list at amazon.com/shop/smashomash. It's resveratrol. So this might be a performance-enhancing substance for some of you. It's got trans-resveratrol, green tea extract, grapeseed extract, vitamin C, acai, pomegranate, blueberry, and more. One of the supplements that I take for maximum performance. Perhaps try it out. Let us know what happens, as you are a living laboratory. So perhaps put some inputs into your living laboratory at Amazon.com/shop/Smashomash. You can also find our homepage at smashomash.com. And by the way, welcome to the Neo Renaissance. You might find a link to our Hemp Lucid shop on there as well, so try that out. Make sure you enter the promo code SMASHOMASH10 and save 10% on checkout. Promo code SMASHOMASH10 to save 10% on checkout at the Hemp Lucid shop. Again, links below the video. You can also find links on the homepage at smashomash.com. Thanks to everybody who has helped support the channel in the various ways. And let's get back to some more solar stuff. Here is the SDO continuum for November 12th and November 13th to date. So, new sunspot just formed right down there, quite spontaneously, and another small sunspot rose way up here in the northeast. So that'll be a little more obvious in the colorized magnetogram. There you go. Same dates, November 12th and November 13th to date. Take a brief look at volcanoes, and only one listed here. I'm not sure if somebody's asleep at the wheel at Volcano Discovery, but we've got Luatolo producing a 6,000-foot ash plume. No other volcanoes listed there for some reason on the Volcanoes Today screen at volcanodiscovery.com. Not sure what's going on there. Perhaps one of the website creators is out pole vaulting calderae. Let's hope not. Next, seismic activity. We did have one 6+ magnitude quake. We'll get to it. We'll cite all the quakes of a 5 or greater magnitude for the past 24 hours. There's the past 90 days. And here are quakes of a 5 and greater magnitude. First one was a Papua New Guinea quake at a 6.1 magnitude, 7:43 Universal Time this morning on November 13th. Next, Tajikistan had a 5.3. That was about 4 hours later there at 12:16 Universal Time. Then Kermadec Islands had a 5.7. Right there north of New Zealand there, near the Kermadec Trench. That 5.7 was at 14:40 Universal Time and over 400 kilometers estimated depth. And those are the quakes of a 5 or greater magnitude for the past 24 hours. And let's get back to the sun here. There's another 24-hour video for you from SDO. That's ionized helium, 304 angstroms, and ionized iron in 335 angstroms. And here's a quick look at the equatorial view in those wavelengths. Now, the 10.7 centimeter radio flux has kind of stagnated here. It's currently at... Hey, that's a good question. What is it at? It is at 134 solar flux units. Here's our custom home-built animation about the radio flux. It comes out of the upper chromosphere and lower corona, the transitional region, the area between the sun's surface and the higher levels of the corona, the sun's atmosphere. In between there, you have the chromosphere. Of course, the photosphere is essentially the surface of the closest star. Here's a one-year graph of the radio flux. It's the black line. And looking at the Space Weather Enthusiast dashboard, it looks like NOAA is expecting a little uptick in space weather, both tonight and on Wednesday night. So see our previous daily space weather videos if you haven't seen our forecasts for geomagnetic activity. There is a CME or two on the way. Again, you can find our playlists, youtube.com/smashomash/playlists. Lots of content from the channel. Next, Earth's magnetic moment from space for the past 4 hours, and let's let that play all the way through. This imagery depicts magnetohydrodynamic pressure, the units of which are nanopascals. So things are geomagnetically calm here. We did see a little bit of a perturbations going on in the solar wind. There's a little minor change happening in the past hour or so. Here's Earth's magnetic moment from the ground. Again, we are in geomagnetically calm conditions here at the moment. This depicts magnetic flux density at the ground level, the units of which are nanotesla, magnetic flux density. So nothing big happened in the past 4 hours. We did see a brief period of minor geomagnetic storm. We got the G1 level there. And it was mainly because of magnetic field, the vertical component of it. So that's the KP index. Current conditions are KP2. KP2 is the current planetary K index, an average of global geomagnetism. So here are some solar wind parameters. We did see the magnetic field strengthen on both the ACE and Discover. We've got some missing data on the ACE here, so let's switch over to the Discover. And the current conditions at the Discover are showing up at about 5 protons per cubic centimeter for the solar wind density, solar wind velocity here, 436 kilometers per second. Again, you can see right in here, a little bit of an increase in the magnetic field strength, but it went into positive BZ territory. So the vertical component of that magnetic field now back into the positive territory, not likely to produce any geomagnetic storm conditions with those kind of parameters. So geomagnetically calm conditions. GOES magnetometers are fairly smooth here. Those are at geosynchronous near equatorial orbits. The M's and N's stand for midnight and noon local time, respectively, for the GOES 16 and GOES 18. The GOES 16 is the red line. The GOES 18 is the blue line. And next, our line of sight ecliptic plane field plot. So there's a sector boundary crossing. Earth is going to snap into a south pole magnetism sector in the coming few hours. And it looks like stereo A is already in a south pole oriented plasma sheet. If you look at the last image right here, I'm sorry, that's stereo B actually. Stereo B here now in a south pole current sheet. So sector boundary crossing is imminent here, expected in a few hours. And let's take a look at some more GONG data, as it's some of the best data there is. Here's our line of sight field plot, as we show some very detailed imagery of the closest star. We give you the big picture, the whole picture, and nothing but the picture. No propaganda, no nonsense, no pseudoscience, just facts. There's the solar B field depicted in blue, polar fields in green and red for north and south respectively, photosphere magnetism in grayscale. Here's our line of sight ecliptic plane field plot. You can see that south pole current sheet headed this way, only a few hours out from when this video was produced, which brings us to coronal holes. What evil lurks in the depths of coronal holes? The Smash-O knows. High-speed solar winds come out of coronal holes. That's a thing. And yeah, let's bring up the last image here. There we go. We've got... So these are North Pole coronal holes. And these are South Pole coronal holes. The line is kind of like this at this point. So there is your 24-hour video featuring SDO 211 angstroms. And expect the uptick in coronal holes to continue for the next year plus, folks. We've been way behind in coronal holes, and now the sun is playing catch-up. Next, we'll move to sunspots. And again, we've got at least 2 new sunspots, but we've got a bunch of setting groups as well. So we may see a net downtick in sunspot number. And it looks like the current sunspot number is all the way down to about 75. So here's our flare monitor and flare probability, our flare scoreboard and probability monitor. And I would say right off the bat that the most likely place to see large flares remains around the western limb. So we've got a number of magnetically complex sunspot groups setting over there. And these new sunspot groups, let's see. So it looks like this group here, 3484, maybe 3485, Anyway, on the western limb is the most likely place to see large solar flares. Let's take a look at sunspots from SDO. There's the SDO continuum. You'll see this new group spontaneously form down here. A little bit of umbral consolidation happening with this group to its north. I should say its northeast. Let's switch to energetic particles and solar flares. No spikes in the proton flux. And flaring has been minimal. Background level of X-ray flux is probably around a B9 to a C1 class background flux. No major flares over the past 24 hours. Let's see where the minor flares have been coming from. Here's a 24-hour video for SDO, 94 plus 131 angstroms. We do have a little increased likelihood of a solar flare up in the northeast, but again, the western limb is certainly the place to look. Sunspots, they're more likely to produce solar flares when they are at the solar limb than when they are in the center of the solar disk. Next, let's take a look at a star chart. That's what's going on overhead at the moment. Saturn and Jupiter up there as Deneb circles the North Star. Kind of like this. So that's your star chart if you want to make your own, skyandtelescope.org. But that's what's going on over our head. And happy new moon. This morning we'll have a new moon. And here's a solar system forecast. That's where things will be in 1 week. Mercury catching up. And next, our astronomy photo of the day. It's the Andromeda Galaxy, taken in time-lapse photography over the Swiss Alps. So fantastic view there of M31, the 31st entry in the Messier catalog. Milky Way's sister galaxy, the more massive Andromeda Galaxy, takes up a big piece of sky. And probably the oldest light you can ever see directly. M31, it's about 4 million light years away, expected to collide with the Milky Way galaxy in a few billion years. Continuing on to CMEs, coronal mass ejections. And here are some images from yesterday. That's 64 frames from November 12th. And unfortunately, we ain't got no frames from today. At least not from there. We do have some from Soho Lasco C3, though. So here's C3 on the right. Let's get a little bit closer than that. That is not sufficient detail for our viewers. There we go. And we're going to let those play all the way through. It's been quiet for coronal mass ejections here, so surprisingly low amount of material coming off of the closest star here. Don't expect that to continue. There are a large number of filaments on the Earth-facing portion of the solar disk. So CME likelihood remains at nearly 100%. Last 24 hours have been surprisingly calm. Only minor events happening. Before we show our custom coronagraphs, we'll show stereo A, located right about there, as it speeds away from Earth in a slightly faster and slightly closer orbit to the Sun. Here's the difference imagery on the right and the raw coronagraph on the left. We show it daily on the channel because, hey, who knows, I could screw up. If I do, at least you'll have the opportunity to correct me in the comments section. Some of us in the realm of science like being wrong. It causes us to learn from our mistakes and plan better for future endeavors. Other people try to gaslight folks when they're wrong, and that's just pathetic. Let's take a look at our custom coronagraphs. Here is Lasco C3 in blue, C2 in red, and SDO 193 angstroms in bronze. So that's a 24-hour video. Let's get a little closer. Let's step in one more step closer, subtract the C3 and add 304 angstroms, you can see a lot of rope-like features there on the solar disk. Those are the kind of filaments that cause coronal mass ejections, and that are coronal mass ejections, I guess, once they exit the corona. And there's a great view from SDO once again. And let's take a look at filaments from Big Bear. So there you go. There's the Big Bear Observatory. And let's do a brief count here. This one is absolutely massive. We'll say that's 1. There's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, at least 13 filaments. Let's make it 14. At least 14 filaments visible on the solar disk right now. That is a lot of filaments. Coronal mass ejection likelihood remains nearly 100%. Here's the grayscale image. It shows prominences as well. And before we get the bonus features, let's take a look at the... Oh, by the way, if you want to name filaments after living people, do it over on Twitter, x.com/smashomash. Thanks to our new follower over there. Oh, geez, one of these centuries we might even reach 500 followers. If you are on social media, make sure you follow us on Twitter. It's where most of the interaction happens, and here are the past 3 hours or so from the GOES 16 SUVI. So that's what's going on. And let's do bonus features, starting out with satellite charging hazards. What do you got? Only minor surface charging happening there over places like India, the northern Indian Ocean. So that's what's going on for satellite charging hazards. The GOES electron flux here kind of cratered. Not quite as high as NOAA forecasted it, I think. That's the past 3 days of radiographic measurements from the GOES 16 and GOES 18. There's the 1-year graph. Still kind of high levels, it looks like there. I think that might need an update. That's from solon.info. And here's NOAA's forecast model. NOAA is expecting a decrease in the electron flux. So we'll have to see what happens with that. I would tend to agree with that. Next, we'll show the F layer of the ionosphere. And feel free to pause the video on this frame if you're not familiar with the temperatures of atmospheric layers, the penetration of electromagnetic radiation through atmospheric layers, and chemical concentration in atmospheric layers. Here's the vibrational frequency of the F layer, one slice of the ionosphere located at about 300 kilometers of altitude. And again, things are geomagnetically calm. We show this daily because you never know when you'll end up with answers to questions not asked in science. So just to give a full picture of what's going on all the way from the surface of the closest star down to the surface of the lower 48, that's what's happening in the ionosphere. If that's Greek to you, don't worry. It's showing vibrational frequency in megahertz. We'll also show the anomalogram. That's anomaly in megahertz from a 30-day median. And actually quite a lot of low-frequency anomalies showing up there. So that little increase in the magnetic fields and the plasma and so on in the past 24 hours has indeed shown up in the ionosphere there. We should be seeing this subside by tomorrow's daily space weather video. There's the latest 2245 universal time ionogram, 2245 universal time anomalygram, and wham! There's the whole atmosphere ionosphere electrodynamics model. Total electron content and anomaly on the left, maximum usable frequency and anomaly on the right. A great snapshot of what's going on. It's the Global Ionosphere Nowcast. One of our latest added on features of the Daily Space Weather Show. Next we'll move to total electron content, which is free electrons to about 12,500 miles of altitude. There is the total electron content over a global scale. Some nighttime anomalies there happening over places like South America and the central Atlantic. We also like to show the total electron content anomaly from the 10-day average over North America. So here it is. that is the scenario for North America. Looks like no major anomalies. We'll close out space weather with the latest continuum and magnetogram. So we'll take a look at this new sunspot first. It is a beta class sunspot. This group here is a beta gamma class sunspot, at least. I'll say that's beta gamma delta class, barely. These groups over here, that one's at least beta gamma class, and so is that one. I think that one might even be beta gamma delta class. Whoa, wait a minute here. Yeah, that one's beta gamma delta class, so that's a very high likelihood of large solar flares up there. And again, we do have a new sunspot that just rose up here as well. Let's take a brief look at that. There is at least one umbra visible there, so that should be considered a sunspot by tomorrow. Anyway, here's the full disk. And let's get to meteorology. We don't want the video to be too long, so what we're showing next is dust mass. Yes, the DUEX. It depicts aerosols at an optical thickness of 550 nanometers. So one of the dustiest places in the world is right there in the subtropical Atlantic Ocean. This is depicting surface winds, by the way, and dust. We haven't shown Saharan dust for a while. So there is a view of the planet's dust, a bunch of dust on the eastern Caspian Sea there, as well as in parts of Tibet, the Gobi Desert, I suspect. So that's what's going on as far as dust. Let's switch to regular everyday wind. There are the surface winds of the eastern world. Here are your jet streams. Jet streams of the central world. Here are your surface winds. Surface winds of the west. And here are our jet streams. We've got a divergence of the jet streams over the central U.S. and a convergence of the jet streams right overhead in the mid-Atlantic states. Next, clouds and fog over the Americas. Here's a shortwave radiation map. Love the NASA GOES Interactive Weather Satellite Suite. There's Crescent Earth for you. And here we've centered the map on the Gulf of Mexico, since there is some action happening in there. And a bunch of hot water remains in the Gulf, so there is certainly a lot of convective potential for things to form. And there is some stuff forming here about to move around the Gulf Coast, which we will show you a forecast on momentarily. Next, our snow depth map, just taking a brief look at what's going on with snow for the Northern Hemisphere. Wyoming's been retaining quite a bit. That's our snow depth map from windy.com. And here's our weather.gov map, and you can see a bunch of gale warnings there, it looks like. Gale warnings around the Gulf Coast. So we've been talking about it for a couple days. If your location is lit, click your location at weather.gov, the National Weather Service homepage, and here comes some forecasts. So first, the pressure and precipitation forecast based on a GFS model. It's a 72-hour GFS forecast. Some additional snow coming, so let's take a look at first total accumulated precipitation. That's all of the precipitation. Fortunately, most of the real heavy rains are going to fall in the Gulf, but there will be some heavy rains coming to especially Louisiana, parts of Mississippi, parts of Alabama, and the Florida Panhandle. Also Georgia, going to see some pretty heavy rains. Also Idaho. And here's our total accumulated snow depth, positive snow depth change. Since there is additional snow, oh, some heavy snow coming to Idaho, and Montana is going to get blanketed fully once again. Almost a complete coverage there of Montana. That's total accumulated positive snow depth change forecast based on a GFS 72-hour model in inches. And our last forecast from Tropical Tidbits that we'll show today is the temperature anomaly forecast, a heat wave Moving across the north-central U.S. there toward the Great Lakes. That is a temperature anomaly forecast in degrees Celsius based on a GFS 72-hour model. We'll also show lightning for the past about 10 hours. Pretty heavy lightning there across northern South America and Central America once again. And here's a real-time lightning map. We've got some lightning in the eastern Mediterranean, folks. There are some strikes going on. And on a global scale, we've got a fairly normal amount of lightning here, about 150 to 200 lightning strikes per minute. We'll close out with U.S. Doppler radar. There's a brief look at the full 50-state view. And we'll focus on the lower 48 view. There's vertical motion in the air column. Ground-based Doppler radar systems. Here's a space-based infrared radiation map showing 3.9 micrometer infrared radiation. The NASA GOES Interactive Weather Satellite Suite once again. And here is water vapor. And you can see all of that convection starting to happen in the Gulf. Here's a recap, U.S. Doppler radar. Heavy rains there around the Gulf Coast. Here is clouds and fog. And there is your water vapor map as the atmospheric tributary makes its way up into the Dakotas. Anyway, since I've become spooked of space by watching a bunch of nonsense on YouTube, I'm making my way back into the bunker. In the meantime, may that solar wind be at your back. And I'm going back to the bunker again. Lots and lots of stupid stuff encourage me to climb in.